Today we're talking about quadratic functions and their graphs. I put this picture up here so that you can see when someone throws the football. That's an example in the real world of a quadratic function. It can be kicking the ball when the punter kicks it, or punter on a football team, or the goalie on a soccer team. Then you get this shape. And that shape, which is the graph of any quadratic equation, is called a parabola. And you may remember that you've graphed these before, but we learned a table of values, and I want to talk to you about what I think is an easier way of graphing quadratic equations. Okay, so as I said, their graph is this U-shaped, and that U-shape will either open up or open down. This is our standard form, ax squared plus bx plus c, and it equals f of x, which is the same thing as y. Now, if a is positive, greater than 0, it doesn't want to work here. If a is greater than 0, then your parabola opens up. If a is less than 0, or a negative number, then your parabola opens down. Okay? When you graph this dotted line, okay, you have it in both of them. That's the line that tells you your graph is going to be the exact same on both sides. So it's symmetric around this line. So this line is called your axis of symmetry. It's dotted because it's not part of this equation and it's not part of the graph. If you choose to draw it, it should be dotted, not solid. Okay. The other part that's really important is this vertex point, which is, in this case, if your parabola opens up, the vertex is a minimum. If the parabola opens down, then your vertex is a maximum, and that's going to be really important on the next lesson. But all we're going to work on today is actually calculating and answering questions about the characteristics of parabolas. So first off, determine if the parabola whose equation is given opens upward or downward. So I'm okay if y'all want to say up or down. Uh, all you have to do is look at the x squared term. Is that positive or negative? Hope you all said positive, so therefore it opens up. Okay, when you look at this one right here, it is negative, so we know that this one opens down. That's as simple as it is. Okay. This is probably the hardest part. Find the x-intercepts for the parabola whose equation is given. If the x-intercepts are irrational numbers, round your answers to the nearest tenth. Okay, so when we do these, your x-intercepts, think about this right here. Okay, x-intercepts, I hope y'all remember, means that I have some x number and y is 0. Because that's where it intersects the x-axis. That's what an x-intercept is. So what you're doing each case is you're setting the equation equal to 0. Okay. If I have a negative x squared for as long as I've been solving equations, I don't want to do that. So I'm actually going to multiply both sides by -1. What's 0 times -1? Yes, it's 0. So that means I can just change the sign of each of these, and now my solving is going to be simpler what we are used to. So we've just talked about how to solve these things. The first thing I'm going to check is factoring. Are the factors of 3 that subtract to give me 2? Absolutely. It would be x plus 3 and x minus 1. They're the factors 3 and 1. And if they're 3 and 1, I didn't want to do that. If they're 3 and 1, if this 2 is positive, then my 3 needs to be positive. Okay? And then as we've learned, x plus 3 equals 0. X minus 1 equals 0. Then I'm going to subtract 3 here, giving me x equals -3. And then I'm going to add 1 here, and that gives me x equal to 1. So my x-intercepts, I would like for you to write them as a point. So -3, 0, and 1, 0. Those are my x-intercepts. Okay, let's look at the next one. F of x equals x squared plus 8x plus 14. So I'm setting it equal to 0. X squared plus 8x plus 14. Now to factor that, I'm looking for the factors of 14 that add up to 8. Well, the only factors of 14 are 1 and 14, 2 and 7, and neither of those add up to 8. Therefore, this thing cannot be factored, so I'm going to use the quadratic formula. So let's refresh. Remember that A equals 1, B is equal to 8, and C is equal to 14. That doesn't really look like a 14. Okay, so when I put it in my quadratic, remember it's all over 2A. So I have negative B plus or minus the square root of B squared minus 4 times A times C. Now, it's going to be irrational. It couldn't be factored. So when you put that in your calculator, you're going to have negative 8 plus the square root of that over 2. And then you're going to have negative 8 minus the square root of that over 2. So you might need to come get some help if you don't get these decimal numbers. So you have x equals negative 2.6 and negative 5.4. So again, you need to work that out on your calculator and make sure you get those numbers. So my answer, of course, would be written. Do not write your answer like that. That's a solving of it, and that's a different question. The question is, give me the x-intercept. So negative 2.6 comma 0 and negative 5.4 comma 0. So again, that's bringing in stuff that we've learned in the past, an application of it. Okay, this one's a heck of a lot easier. Find the y-intercept. Okay, so the y-intercept is, of course, 0 comma y, whatever that is. Well, the lovely thing about that in your quadratic formulas, okay, if I have, excuse me, quadratic equations, f of x equals ax squared plus bx plus c, okay? If you put in 0, that term goes away. Put in 0 for x. That goes away. That goes away. And this is always, always your y-intercept. So if you look at this first problem, x squared plus 8x plus, oh, there's nothing there. So it's like plus 0, which means that my y-intercept is going to be 0, 0. Nothing there. What's it going to be here? That number. So my answer is 0, 5. Okay. Now, as we said, the vertex of the parabola is very, very important. Okay. And you'll use it to solve applied problems the next lesson. When you have it in standard form, ax squared plus bx plus c, the x coordinate, sorry, the x coordinate of your vertex can be found by taking negative b over 2a. And then once you get that, you're going to substituting the x-coordinate back into the equation to find the value at that point. So let's do an example. We're supposed to be finding the vertex, okay? Now, I don't know, I'm going to write it like this. Some people will get it. You'll see it this way later. Basically, your x is this, and your y is what happens when you take that number and you plug it into your function. Okay, so I'm going to go find, this is A, B, and C. A is negative 2, B is negative 4, and C is negative 2. So negative B over 2A is going to be negative. Remember, I asked you to always put parentheses around a negative number when you're plugging it in, over 2 times negative 2. Okay, so we have 4 on the top and 4 on the bottom, and I have 3 negatives. So whether you can see that or need to punch it in your calculator, it's negative 1. And now I'm going to go figure out what do I get when I put in negative 1. So that's negative 2. I got a negative number again. We're putting parentheses around every time we insert it into the equation. Okay, and when you put that in your calculator, that gives you 0. So your vertex is, I always put a V there so we know what this point represents, negative 1, 0. Okay, and looking at the next one. Okay, doing the same thing, I have negative b over 2a. A is equal to 1, b is equal to negative 6, c is equal to 5. So negative negative 6 over 2 times 1. Two negatives is a positive. 6 divided by 2 is 3. All right, and then I'm going to go calculate f of 3. So I'm putting in 3 right here, which means I'm going to put 3 into that equation. And that gives me 3 squared minus 6 times 3 plus 5. And put that in your calculator, and you should get negative 4. So your vertex here is 3, negative 4. You should pause, make sure you know how to put these in your calculator. Okay, that lets you know that you understand what's being taught. Okay, so now we're going to talk about graphing. Okay, um, to start off with, what we just did is a very, very important step of graphing. So the first thing we have to do is go figure out negative b over 2a because we have to find that vertex. So negative, it's not a negative 2, so I did not want to do all that. Okay, b is 2. B over 2 times a is negative 1. Two negatives is a positive. 2 over 2 is 1. And then I'm going to calculate f of 1. And that's negative 1 squared plus 2 times 1 plus 3. And that, of course, gives me 4. So my vertex is 1, 4. Uh, 1, 4 is my vertex. The other thing that you always want to do when you graph is after you find that vertex, you want to say to yourself, is that going up or down? And this one is going down. Okay? So it's going to do something like this. Now, this next thing that I'm going to tell you is something that, like I said, if you understand it, will make your life easier. If not, please come ask me questions. Okay? But I'm going to tell you the key points from the parent function of y equals x squared. If x is 1, 1 squared is 1. If x is 2, 2 squared is 4. If x is 3, 3 squared is 9. So what I'm doing is I'm going to use those key points every single time I graph. And I'll do an example of when it changes. Okay, so always from your vertex point, and because you know it goes down, then I'm going to go over 1, down 1 in both directions. Remember how we had our axis of symmetry down the middle, so it does the same thing on both sides. And if you want to, I can go ahead and graph that for you so you can see. Thanks. There's my axis of symmetry. So from here, over 1, down 1. If I go over 2, I'm going down 4. Over 2, excuse me, 1, 2, down 4. Now the other way, I'm doing that on both sides, but you can also go 1, 2, 3, and then down 9, which puts me here. And once you get one side, just count back over. 1, 2, 3, 1, 2, 3, over to the other side. Okay, so this is my parabola, and I'm going to do my best to draw it on this thing, and that wasn't very good, so let me try that one more time. But I'm not going to spend a lot of time on it. It's easier on pencil and paper, but you do need to make sure that you, okay, I may have to pause and do that. Yeah, I do need to try to get all the points. There we go. It's a little bit better. Okay, you got the idea. Okay, let's look at the next one. We have negative b over 2a. So the first thing you're doing is finding that vertex. Negative 4 over 2 times 1 is going to be negative 2. And f of negative 2, okay, parentheses are so important at this point, y'all. Negative 2 quantity squared plus 4 times negative 2 minus 5. And that equals negative 9. So my vertex is, didn't write that correctly. Try that one more time. No, 5. uh, equals -9. My vertex is -2, -9. So that's my starting point, -2, -9. Then I said, does it go up or down? Okay, A is positive, so my parabola is going to open up. Okay, um, here is my axis of symmetry. Let's see if I can make it a little skinnier. Let's try that one. I don't know what I'll do. Nope, it's not any skinnier. Okay, -2, -9. Okay, so I have my vertex point right here. Okay, now I'm using my key points. And from here, I'm going to go over 1, up 1, because I know it goes up in both directions. I'm going to go over 2, up 4. 1, 2, 3, 4. Sometimes 1, 2, 1, 2. That's an easier way of doing it. Oh, you know what, guys? I went too far down. Let me start that over again. This is -9 right here. The bottom is -10. Maybe I should put that in a different color because it's kind of hard to see. There's my vertex, -2, -9. Now when I go over 1, up 1, I'm here and here. Over 2, up 4 is here and here. Over 3, 1, 2, 3, up 9. Ooh, well, there's 9 away. And let me do my best to try to connect. It's so hard it doesn't look very good, but y'all got the idea. Okay, one of the other reasons I like this method, okay, I don't know if y'all remember, that right there is my y-intercept, and that says -5, which is exactly what it is in my equation. So that lets you know that what we're doing is correct. Over here, it's +3, which again matches my equation. All right, so I'm going to do two more, some that look a little different, okay, and then we'll be done. So this next one, vertex is -b over 2a. Well, what is b? That's a, and that's c. So b in this case is 0 over 2 times 1. So that makes my x-coordinate 0. And f of 0 is -4. So my vertex here is 0, -4. Does it go up or down? It goes up. So I'm going to plot 0, -4. I'm going to go over 1, up 1 on both sides. Over 2, up 4. And over 3, up 9. Okay, and when you count those points, you're always going back to what your vertex is. Such a really bad looking parabola. Okay, y-intercept -4, that matches with my graph. Okay, this last one I want to show you is a little different, and I hope you can see what's different about it is that a is not equal to 1. All these other ones, a was equal to 1. A is equal to -3 this time. So we have -b over 2 times a, which is -6 over -6, or 1. And then f of 1 is going to be -3 times 1 squared plus 6 times 1 minus 2, which gives us 1. So my vertex is 1, 1, and my parabola goes down. Okay, so I'm going to plot the point 1, 1. Now, as I said, this one is special, very different, because in this problem, a equals -3, not 1. So when I had those key points on there, I'm going to write them up here for you, that said 1, 1, 2, 4, 3, 9, okay? When you have an a other than 1, it affects your y values. So now my new key points are 1, and then you're going to multiply each of these by a. So 1 times -3 is -3. 4 times -3 is -12. And then 9 times -3 is -27. So now when I start at 1, if I go over 1, I don't go down just 1, I'm going to go down 3. to here. Count to my axis of symmetry. I didn't graph that. Let me go put that on there. So y'all can, let's try the weight. Maybe that will help. That's a little better. So there's my axis of symmetry. Um, okay, so I went over 1, down 3. If I go over 2, 1, 2, I'm going to go down 12. Well, that's 11, so 12 is actually right here off the graph in both cases. And I counted back over 1, 2, 1, 2. So my parabola is going to look like, oh, good grief. No, that's not what I wanted. I wanted that one. Okay. I will put a graph on there and then you'll be done. You don't have to watch me do this because if I miss it, I'm going to make it try to match. So ask questions. If you have any questions, please come see me.